Myself Dr. Sharmila, Assistant Professor, Department of Computer Science, NGM College, Pollachi. Now I am going to discuss the topic about graph theory. Graph theory is used in many disciplines such as electrical engineering, physics, chemistry, computer science, computer network, etc. These are the contents we are going to see now. Introduction to graph. Graph consists of a set of vertices and set of edges. Here capital V is the set of vertices and E is the edges. Here G equal to V comma E, it's a ordered pair represented as a graph. This is the example for graph. The graph G contains 4 vertices V1, V2, V3 and V4. There are 6 edges E1, E2, E3, E4, E5 and E6. In short, G equal to V comma E, where capital V is a set of vertices V1 to V4 and E is the set of edges E1 to E7. Self loop. Self loop is a edge that connects to a vertex to itself. A simple graph contains no loops. In the graph G, E6 is a self loop. Next one is the parallel edges. Parallel edges means there is more than one edge present in the pair of vertices. This is called parallel edges. In the graph G, the edges 10 and 12 present in between the vertices A and simple and multiple graphs. Simple graph means a graph that has no self loops or parallel edges is called a simple graph. Otherwise it is called a multiple graphs. Here G1 is a simple graph. G2 is a multiple graph because it has a loop. And next one, weighted graph. Weighted graph is a graph that is a special type of graph which the edges are assigned some weights, that is a positive number assigned to the edges. That positive numbers may be cost, distance or many other relative measures units. This is the example. Next, finite and infinite graph. Finite graph has a finite number of vertices as well as the finite number of edges. Otherwise, the graph is called infinite. Adjacent vertices. In a graph, 2 vertices are said to be adjacent if there is an edge between 2 vertices. Here, the example of adjacent vertices, it has 5 vertices. The vertex 1 is adjacent to vertex 2 and 3. The vertex 2 is adjacent to 1, 3 and 4. The 3 vertex is adjacent to 1 and 2. The vertex 4 is adjacent to 2. The 5 is not adjacent to any vertex because it is not connected to any other vertex. Next one, degree of a vertex. The degree of a vertex is the number of edges connecting to that particular vertex. The self loop is counted as twice degree. In this graph, the degree of the vertex V1 is 3. The degree of vertex V2 is 2. The degree of vertex V3 is 5. Degree of vertex V4 is 4. Isolated vertex. Isolated vertex means a vertex with the degree 0 is called the isolated vertex. A vertex with degree 1 is called the pendant vertex. Next one, matrix representation of a graph. A graph may be represented in the matrix form. Matrix contains the rows and columns. There are 2 methods to present the graph in the form of matrix. The first one is adjacent matrix, second one is incident matrix. Adjacent matrix is a square matrix of n into n size, where capital N is the number of vertices in the graph and it is used to represent the connections between the edges of a graph. Here Aij is 1. There is a edge between vertex Vi and Vj. Aij equal to 0 if Vi and Vj are not adjacent. This is the example for adjacent matrix. Here rows and columns are represented as a vertex V1 to V5. If V1, number 1 is present means the vertex V1 and V1 are connected. Next one, incident matrix. Given a graph G with n vertices, E number of edges and no self loops. The incident matrix Xij of the other graph G is an n into E matrix where Xij equal to 1, J edge Ej is incident on the ith vertex, Xij equal to 0, it's not incident. This is the example for incident matrix. Here rows are represented as a vertex and columns are represented as edges. The number 1, the vertex is, the edge is incident on that vertex. The entry is 0, the edge is not incident on that particular vertex. Null graph. Null graph means a graph with no edges is called the null graph. Here 5 vertices are presented. The 5 vertices are isolated vertex because each vertex of the degree is 0. Thank you.